put in it first, and then put that answer into the g function. Now we just had f with 4 in it, so I won't do that again. The answer is 10. So put that into the g function. G with 10 in it is equal to 1 over 10. So the giveaway here is in the marks. If it's only 1 mark question, it's going to be quite straightforward. Sam?
Why does sometimes the function of x doesn't equal 0?
Okay, yeah. So this thing, why it doesn't have x cannot be 0. It's kind of, this wouldn't be a function if x was allowed to be 0, because it would be 1 over 0, which is undetermined. Sometimes, like at this level, it's unnecessary to put it in. It's almost confusing to put it in, but it's just stating that there is an asymptote at x equal to 0. Yeah, good question. So you don't need to deal with that unless you get an answer for this function. You're looking for an answer, and one of the answers is 0, and then you just disqualify that as an answer. You just ignore it as an answer. All right, let's keep going. G with 5 put in it, so that's G with 5 in it is 1 over 5. And then put that into the g function itself. So that's 1 over 5 into the g function again, which is 1 over 5. This would be in the calculator section of the test, so you could try to divide 1 by 1/5. Does anyone, what do people write here? Sheil? The answer is 5. Yeah, how often, how much does 1/5 fit into 1? Well, 5 times. That's one way of looking at it. Or you can do your keep, change, flip for your fractions.
So,
Yep.
or like when there's like 3 of them, like 2 numerators, can we just swap the fraction? Like,
You swap the fraction.
yeah, put the 5 over.
Yeah, you can. Yeah, but don't think of it as general rules like that. Try and logic it out each time. Don't have a general rule that might let you down in specific cases. Anyway, so this hx needs to go into f, and then let that answer equal to 10. So you got to deal with the x's first. So hx is x plus 2 squared. Yes, Joe?
I just need to give this to Sam.
Oh. Awesome. All right, so that's the fx function, or that's the hx function. That needs to go in to fx. So fx is normally, I'll write this, you don't have to, 3x minus 2. So instead of x, we got to put this thing in. So it's going to be 3 times x plus 2 squared minus 2. Okay. So what order do we do this in? Order of operations, brackets. Can I add x plus 2? No. Exponents next. Can I square out this brackets? Yes. So that's what I'll do next, and I'll do it up here. So that's 3 times x squared. Now remember, x plus 2 times x plus 2, if you're wondering where I'm getting these answers from. X squared plus 4x plus 4. Hopefully that's automatic at this stage. The 2 times 2 gives us the 4 at the end, and then the 2 middle terms multiply to give and add to give 4x minus 2 here at the end. Then keep going back to BEDMAS, order of operations. Still can't add anything in the brackets. I've squared already, so the next thing comes either division or multiplication. So I'm going to multiply, because there's multiplication to be done here outside the brackets. So we've got 3x squared plus 12x plus 12. I'm going to multiply it, then take away the 2. And now I have 3x squared plus 12x plus 10. And all of that needs to equal 10. So I've done a lot of work here. 3 mark question, expect a bit of mark, at least 3 different steps. Sheil? That's x, 12x.
Below the 3x plus 2 squared.
That's just x plus 2 times x plus 2. I'm just saying that that's squared. All right, so I think the 10s cancel. And you're left with 3x squared plus 12x is equal to 0. I'll just factorize it down here. Take 3x out, and we're left with x plus 4 in. Hopefully you're able to factorize like that. If it's a 2-term quadratic without the last term, you just take out one of the x's like that. And then still let each bit equal 0. So 3x equals 0 and x plus 4 equals 0. That's how we finish it. So x must be negative 4. Because only negative 4 plus 4 would be 0. So that's one answer. And, well, dividing both sides by 3, we still have 0 here. So your answer is 0. Okay. And this has nothing got to do with the gx function. So the answers, if you remember, the answer can be 0. That's fine. All right. And now, this question. Fx into hx, that answer into gx. So fx is 3x plus or minus 2. That needs to go into h. So 3x plus 2 into h. H is the x plus 2 one. So that's going to be 3x minus 2 plus 2 squared, which is just, well, that goes, which I think is 9x squared when you multiply the 3x by itself. And that answer needs to go into the gx function. Oh, instead of 9x squared goes into the gx function. There's 1 over 9x squared. And that's it. Okay. So hopefully you did well on that first page. Part C was definitely the most difficult part there. All right. Simple interest, compound interest. You're going to need to know these. So simple interest formula is the principal times the interest rate times the number of years. And that will give the interest. Principal times the interest rate times the number of years. P times I times N. So the principal is the amount you put in, so that's 450. Times it by the interest rate. Now the interest rate must be written as a decimal. So that'd be 0.035. That is, if you don't know how to turn that into decimal, just divide by 100 on your calculator. Turning a percentage into a decimal. And then the number of years is 5. So you'd be definitely expected to use a calculator here. 450 times 0.035 times by 5. And I get 78.75. Is that the answer? Rhetorical question. No, it's not. Because that's just the interest we've calculated. When you do simple interest, you calculate just the interest. You need to add that to the principal to get the total. So 450 plus the 78.75, and that gives 528.75. And this was a show that, so you need to do all that. Yeah. Don't say there's a different way or it's easier. There's many ways. It's just multiplying 3 numbers together.
Oh, like we can just, I can just went from if we add like the 150.
Okay, if you add it, yeah. Yes, you can, yeah. All right. Compound interest then is different. This is I think this was a 4-mark question or a 3-mark question. I managed to cut it out. Difficult question. So this dude invests 450 for 5 years at the rate of X compound interest. So we have an interest rate of X. We don't know what that is. All right. Does anyone know the formula for compound interest? Shia, do you know it?
It's like the amount of money at the beginning multiplied by 1 plus x over 100.
Okay, so you need 1 plus X over 100, is it?
No, just the x over 100.
Just the X is over 100?
Yeah, and all of this in brackets.
Where'd you get this from?
From my desk.
You knew it off by heart?
No, I just like remember it from the beginning.
Yeah, upset I wrote this down. But yeah, you're on the right track. Yeah, you can do that. But what happens if we don't remember the compound interest formula? Perhaps you can think a little bit about compound interest in general. You have 100 at 10% for, let's say, 5 years. If you put in 100 the first year, you get an extra plus, how many? $10. So at the end, you have 110. That's the end of the first year. Now the whole thing is you need to put 110 in the second year. Now, how much is 10% of that? 11. Okay, and then you end up with 121. Okay, so you're always getting 100, you're always getting 10% of this new figure. But what you can think about is if I just created a multiplier, what would the multiplier be? 100 multiplied by something gives 110. 1.1, because it's 110%. That is, after 1 year, it's 110%. So 100 plus 10%. And then I want to get 110% of whatever this answer is. So let's say you found this answer, and you want to get 110% of this, you multiply by 1.1 again. And that'll give the second year. You do that again and again and again. We shorten that down. The principal multiplied by the interest rate, but as a 1 point something. And instead of a constant multiplication, that becomes a power to the number of years. It's powered, so the interest as a decimal. So let's talk about our question. So we've 450 multiplied by some interest rate, but we know it's 5 years, and that gives an answer out of 530.6. We just don't know what the interest rate is. That's the problem. Okay. Let's call it X. Interest rate. Now, if I want to undo, so it's 450 times X, a certain number of times. If I want to undo that, how can I undo to the power of 5? Sorry, this shouldn't be in brackets. Sorry, this shouldn't be in brackets. Only the X is to the power of 5, not the 450. The 450 won't be to the power of 5. That X should be. I put the brackets in the wrong spot. My bad. Because if you did 450 to the power of 5, that'll be an absolutely humongous number. But it's only the interest rate that multiplies by itself again and again and again. Okay. So first thing, I can divide both sides. So that's X to the 5, and then divide both sides by 450. 530.6 divided by 450. We're going to need a calculator for this. 530.6 divided by 450. And it gives 1.1. X to the 5 is 1.17911 loads of ones. Okay, is that my interest rate then?
It's 18%.
It's 18%? Oh, I'm not there yet. That's X to the 5. I want X. How do I get what X is? I need to do the fifth root. That's X multiplied by itself 5 times. So we need to get the fifth root. So you need to go to press 5, math, and go down to the root sign. And that gives you the fifth root. So 5 math root sign of 1.179. Now those without a calculator aren't doing that. What answer do we think we're going to get? A roundabout is going to be 0 point something. Really small number because it's the fifth root. No one knows. Okay, let's see.
It's going to be like 1 point something.
I hope it's going to be 1 point something.
It is.
It is 1 point something. 1.0335. What's Yes. The interest rate then is 3.35% because this is 103.35. So the interest rate is 3.35%.
So,
Yeah.
what happens if you don't make the calculator for this?
Next question. X squared minus 3x minus 10. Factorize it. So this is back to being easy. So that was a 4-mark question, so hence there's quite a number of steps. Do remember the 5th root button or the 4th root, you need to go to math on the calculator. This hopefully you could factorize quite quickly. X and x, I think 5 times 2. This makes 2x here. This makes 5x. I need to make a negative 3x, that term in the middle. So that has to be minus 5 plus 2. So the minus goes to the 5 and the plus goes to the 2. So that's x plus 2, x minus 5.
Wait, so,
Yes.
for the question above it, can you stick the formula straight to the calculator? Or what?
Can you stick it straight into your calculator? Does your calculator have the compound interest formula?
Else?
You could solve it if you want, yeah. At this stage, can you solve it using a calculator? Yeah, you can, yeah. So it's 450 x to the 5 is equal to 530.6. If you graph this and graph, see the numbers are quite large, it'll take you a while to get the point. If you graph these two things, or if you graph 450 x to the 5 minus 530.6 equal to 0, if you graph that, you'd find the zeros and that'll be your answer. I think it's easier this way. Yeah. Sometimes the graphing method is not our friend. It could help you if you have time to go back and double check your answer, maybe. All right. Use your answer from part A to solve this. Solve inequality. So x squared. All right. So let's think about our x and y axes. This graph. Well, what do we know about these two things? These are
The intercepts.
which intercepts? X or y?
X.
X. So at 2 and minus 5, is it?
Yeah.
Is it?
Yeah.
I'm saying it again for another option. What's the answer? So if you want to find the intercepts, you would let this equal 0, wouldn't you? And then you would solve each bracket equal to 0 and you'd end up with the opposite signs. So x would equal 5 here and x would equal negative 2 here. So this graph cuts at negative 2 and 5. It's a quadratic graph. We should know the shape of that. It looks like this. How do I automatically know it's a happy face and not a sad face? Because it's positive x squared, yep. All right. Which parts of this graph are above 0? And notice the way the 0 here is instead of the y, not the x. So which part is above 0 on the y-axis? So here's 0 on the y-axis. Which parts are above 0? Everything before minus 2 and everything after 5. Everything before minus 2 and after 5 are above 0. So how do I solve that? The answer would be x less than minus 2. When x is less than minus 2, it is above the curve, or above the y-axis, and x greater than 5. You can write those the other way around, but that's the way the symbol. So x is less than negative 2. It's all of these numbers back here and these numbers there for the x input.
I would think it like this. Why are we looking for like the one after 0? Like how do we know from the question?
That it's not this bit down here.
Yeah.
So where is this graph above 0? Remember, a function in general, this is the function. You could write that as fx equals, or you can write that as y equals x squared minus 3x minus 10. And what has y been replaced by? Greater than 0. So where is this on the y-axis bigger than 0? Above 0. Here's the y-axis. All these numbers are negatives. All these numbers are positives. So above 0 on the y-axis. It's always going to be some number here, usually 0. Like if it was at 1, it'd be different because you'd have to solve where it's above 1. Yeah.
For the whole test, are we allowed to use your calculator?
Are you allowed to use calculator for the whole test?
Yeah.
Okay, but for these questions, the working out is worth the marks. Is worth 1 mark, and the answer is worth none marks. So you got to show something. For this, you can. This is just an answer, so you could have used your calculator to graph this.
How do we know that we don't need to show the
So read some of this. Show that something. Show that versus find the value of x. Technically, you didn't have to show any working out here, but it would have been really difficult to do without working out. So that's the notice for show that, and here you must show all your working. It generally will say it. If it doesn't say it, you can just presume. You can write nothing and just have a guess. All right, simultaneous equations will definitely come up. It'll probably be a 3-mark question like this. 3 is cut off again. 3x minus 2y is equal to 11, and I'm just rewriting 5y is equal to 10. I draw a line underneath. I've got 2 equations I want to eliminate. I use elimination. You can use substitution, but you need to eliminate either x's or y's here. A multiplication of both lines is required, I think. I'm going to eliminate x because most people seem to like to eliminate x. I'm going to multiply this line by 4 to make 12x and this line by 3 to make 12x. Multiplying the top line by 4, so if you want, you can call them a and b or something like this. 12x minus 8y is equal to 44. If I multiply the bottom line by 3, I like to multiply by minus 3. So I don't have to subtract, I just add. Now, some people like to multiply by 3 and then subtract. It's up to you, as long as the x's cancel. I get, when I multiply by minus 3, minus 12x plus 15y minus 30. That now disappears. 12x take away 12x is gone. So that's 12 minus 12x. I'm adding. I'm not changing any more signs because I've done it here. Plus 15y minus 8y combined to make positive 7y. 44 minus and minus 30 make positive 14. And y you can see here is 2, hopefully. Once you know y is 2, go to either of the 2 equations. 3x minus 2 times 2 now. I know what y is. So I've taken this first equation and let y equal to 2. 3x minus 4 is equal to 11. 3x is equal to, I think that's 15 if you add 4 to both sides. And x then is 5. So x is 5, y is 2. You can always test, of course, your answers to make sure, if you have time, substitute them into either equation and they should definitely work. Okay. All right, function, sketch it between 0 and 4, calculator out straight away, clear anything that was there before. If you want to set the window first, it's not a bad idea. The x minimum is 0, and the x maximum is 4. That's all I want. The y minimum is -2. Make sure you use the negative button. And the y maximum, 12. Okay, so I've set my, and then I'm going to type in 10 plus x minus x squared graph. Okay. Sketch the graph y is equal to fx. So what bits of information should I put on this? 2. The general curve will be 1 mark, and the 2 intercepts will be the other mark. So the general shape of the curve. The 2 intercepts, hopefully you're getting quick at intercept of the y-axis. It's just going to be the number without the x. It's at 10. I don't even need to check on my calculator. Let x equal to 0, you can if you want. To find this other thing, this is called a 0. where y is equal to 0. You can get it using your calculator. If you press second calc, go down to 0. The left bound it looks for, so anything on the left-hand side, I'll just move it closer for no reason. I'm putting the left bound here. I want the right bound to be the other side of that line where it crosses. Here, press enter, and I see it's at 3.70. 3.70. Okay. So once I have those two things, so here around 3.70, I can just connect like it looks on my calculator and try and get it to go through that point, and that's it. Yes.
Will we lose mark if we don't like draw the things so it's like really precise?
Sketch. No. Right down where the graph crosses the axis. Great, we've this done already. And this is helping with your sketch if you forgot to do it earlier on. It crosses at 0.10. 0.10, that's there. And it crosses at 3.70 and 0 for y. That's the name of those 2 points.
So,
Yeah.
on the sketch, do you have to put the coordinates?
I would recommend putting them in, yeah. Yeah. So if you see 2 marks, you're generally looking at 2 bits of information. Anyway, I know I have 3 bits technically here because the curve is another bit of information, but just drawing the curve, you only get 1 mark. Solve fx equal to 1. There's 2 ways of doing this, algebraically or just using your calculator. Let's use the calculator because I think that's where most of you are perhaps struggling how to use the calculator. Draw a line at 1. Graph. They intersect. That's what you want to find. How do I find the intersection? Press second, calculate, and there's an intersection. I moved the left on the first curve. I'm going to put to the left of it. Enter. On the second, oh, I didn't mean to press that. On the second curve, put to the right of it. Intersected again. Enter. Just put to the right. Enter. Ask you to guess. Don't bother. Just make sure your X is flashing on the point you expected. And we get 3.54.
So I took 15 minutes with the algebra.
Yeah, you could do it algebraically, but as you said, look, the clue here is there's only 1 mark. If you're spending that long, the calculator should be involved. Well, and there's always that problem. And it'll be 1 mark or no marks because you're not expected to work it out. So if you just get it wrong, you just get nothing. So try and get used to using your calculator for a solve like this. Rearrange this to make x the subject. Okay, so this is solving for x. This is a difficult one, I think. I'm going to start by multiplying both sides by a common denominator. So multiply both sides by bx plus c. That's a denominator. Now, this cancels with that. So I'm just left with y times this. So I'll do all that. Y bx plus yc is equal to ax. I need x on its own to make x the subject. So anything with x, I'll bring over to one side. Subtract ax from both sides and subtract yc from both sides. So I'm going to talk about swapping sides or something that you can. So x's are gathered together. There's 2 x's. I only want 1. The only way to get rid of it is to factorize. Factorize x out. You get yb minus a. So x is gone from both these. It's factored out. Is equal to minus yc or cy, whatever way you want to put it. Divide both sides now by this. And this is your answer. X is now on its own. So if you want, I think in maths we try and write letters in alphabetical order. So I've changed YC to CY, but that's okay if you the other way around. And BY minus A, or like this. Either of those, fine. Whichever way. That's okay. All right. So quite often that these make the subject or solving for a letter tend to use factorization as the kind of tricky part of the question. Question 7. Find the image of the point 5, 1 under transformation P. Okay, so this is one where you have a grid to help. You don't have to use it, but it might be useful. P is rotation 90 degrees anti-clockwise about the origin. So how do I use the grid to help? Just draw it. Just draw the XY axis anywhere. You can just do sketch. It's only a sketch, so I'm going to quickly sketch because I don't have much time. Okay. 0.51. Oh, I'm not sure how many boxes to use, so I'll use maybe 5 at a go. 2, 3, 4, 5. This is only a sketch for my using, so I haven't really drawn it very well, but okay, something like that. 5, 1 is 1, 2, 3, 4, 5. 1 is around there. Right. Anti-clockwise, you will have access to tracing paper in the exam. So we should have perhaps asked for this yesterday if you didn't. The origin is this point here, 0, 0. Here's my point I need to rotate. 90 degrees anti-clockwise, so the clock ticks this way, so I'm going to spin it the other way. 90 degrees. Okay, it's up here somewhere. Now it's got to have some relation to 5, 1. Okay, so it's somewhere up here. Now, even on my sketch, hopefully you can see that it's going to be around 1, or minus 1, should I say, on the x-axis. And it's somewhere up here on the y-axis. Where do we think it's going to be? It's going to be at 5. Look at the point. 5, 1. Minus 1, 5. It's going to be some translation. A rotation will keep, if it's about the origin, if any rotation about the origin, it'll keep the same two numbers. It'll just either change the signs or change the numbers. But that's why if you did it perfectly to scale, you would find that this is up here at 5. I managed to use the wrong amount of boxes. Yeah.
Would that have anything to do with the fact that it says 5, 1 and now it's minus 1, 5? Like
Didn't I just say that?
oh.
Yeah, it has. Yeah, exactly. Yeah. If it's about the origin. Yeah, if it's a line going through the origin, like we're going to see in a second, or the rotation is about the origin, it'll keep the same points, the same numbers, but they might be negative or they might be swapped. Okay, 5, 1 under transformation. Q, y equals negative x. This one is y equals positive x because it goes through 1, 1, 2, 2, 3, 3, 4, 4. We need the opposite one, so it's going to be a line like this. That's y is equal to negative x. That'll go through 1 minus 1, 2 minus 2, and so on. So that's y equals negative x. Once again, this is just a sketch I've drawn. This won't be marked. I know it's going to have something to do with 5, 1 again, because this is the line going. This is a line going through the origin.
The same thing but negative.
Well, let's see. Every time what y equals, it now equals negative x. That's one way of looking at it. Anyway, this reflection is a reflection of this line. So this point has to go to this line and go the same distance the other side. So it's going to be down here somewhere. So it's got to look at itself in the mirror. And that's just helped me because I know the numbers 1 and 5 are going to be involved some way. Look where this is. That's at minus 1 on x, but it's at minus 5 on y. Okay, so hopefully that makes a bit of sense. Describe fully a single transformation equivalent to P followed by Q. So a 90 degrees clockwise turn. Sorry, I'm off screen. And 90 degrees. So this has gone to here. And then if I wanted to transform that over a Q, so something here, oh, what's going to happen? Where is that going to be? So remember what this point was. That was the point minus 1, 5. So that was the P transformation, 90 degrees anti-clockwise. But now this one, it's not done from this point. Now it's done from here, reflected over. So it's somewhere around here. Probably there-ish, I imagine. Maybe here. Let's have a think. It's over this side anyway. What's the point going to be, do we think?
Reflection over y-axis.
It's just going to be a reflection over the y-axis? Oh, that's your answer? Why? Because the new point's going to be minus 5, 1? Yeah. So this new point, if you did the translation, which I'd recommend, is going to be minus 5 on x and 1. Yeah, it's going to be here. It's not going to be way down here. And that would ring alarm bells because that's not going to include these two numbers again. Yeah.
Also, for this question, as if describe the transformation, can you use the form for the vector where it says to move it?
The translation?
Yeah, translation, can you say that?
No. No, because the translation is very specific to one point. This is only a reflection. So how do I describe how I get from here to here in one move? It is a reflection. And 2 marks means 2 bits of information. You can either say in the y-axis or in the line. What's the line called? X equals 0. Well, that means the same thing. Sheil?
But on the side of like drawings, like we have to like count a amount of things like the boxes to know to, because if we don't like for the same ones, then we just like do random lines for each unit. It's not gonna work. Right?
If you don't do it accurately,
Yeah,
it's not going to work yet. So do it accurately.
I think there's too much boxes.
Okay. All right. Solve this. X's on both sides. First thing, get rid of an x or x's from both sides. Try and get them over to one side. So I've subtracted 5x from both sides to leave me with 2x plus 9 is equal to 17. Now I want numbers on the other side, so I subtract 9 from both sides. I'm doing this with full working out. 17 take away 9 is 8, and x then we know to be 4. Okay.
So that one we need to show working out.
If that came up in the exam, it would say show you're working out. That was taken for paper 1. All right. Solve the equation. Give your answers to 2 decimal places. You must show you're working. All right. Hints here. Give your answer to 2 decimal places. Suggests not a whole number to me. It's not a calculator question, so cannot draw. So if it was a calculator, you could just draw these 2 functions and let them equal each other, see where they cross over. 2 decimal places. This is a quadratic if it is rearranged. Let's rearrange it first. 4x squared plus 3x minus 12 equals 0. I just brought everything to one side and ordered it like a quadratic. 2 decimal places. What do we think? Sheil?
It's all we gotta do is a formula.
Yeah, it's going to be with the formula. You're going to get a decimal.
Are we gonna get the formula?
Yeah. You will get the formula. X equals minus b plus minus b squared minus 4ac all over 2a. In this case, a is the number in front of x squared, 4. B is 3, and c is the last number, negative 12. Minus b plus or minus the square root of b squared, which is 9, that's 3 squared, minus 4 times 4 times minus 12, all over 2 times a is 8. Now this is a calculator question. You can't see?
No. Yeah.
Okay. This is a calculator question, so you can use the calculator. You just have to show you're working how you figured it out. If you want to work out this bit, 9 minus 4 bracket 4 bracket minus 12 bracket, if you want to do it that way. You get 201. So it is minus 3 plus or minus the square root of 201 over 8. To get two answers then, you take it with plus, take it with minus, get an answer. So let's minus 3 plus square root, I'm doing it on the screen, 201. Get the answer for that, divide it by 8. 1 point, that's with plus, it is 1 point, or what's it rounded to? 3 significant figures, what will that be? 1.40 if you want to write in the third significant figure. Yep. And then do it the other way. Minus 3 minus square root 201. Press enter and divide then by 8 minus 2.15. Okay. All right, so solve using formula. Solve the inequality then. Oh, right. So this is similar to the question we had before. Inequality, let's do a little rearrange here. 4x squared plus 3x minus 12 is greater than 0. So it's a very similar question to what we had the last time. I've rearranged this. I've let not equal 0, but unequal 0, unequal 0. I haven't broken any rules of inequalities because I haven't multiplied by minus or anything like that. Where is this function above 0? Again, it comes up. Where is it above 0? You know it's a U-shaped graph. You know it goes through the x-axis at 2 places. It's going to be above 0 before here and after here. It's not a sad face graph because it's positive. Do we know these 2 places? Yes. We just figured them out. So this is the minus 2.15. So when x is less than minus 2.15 and when x is greater than 1.4, it is above 0. Next question. Note the 4 marks. So this looks a lot like this, except for there's a 5 involved. Well, let's see what that 4x squared plus 3x minus 12 is less than or equal to minus 5. Just switch it around a bit. Okay. Why did I do that? Well, I recognize that this is the same function. So where this function is less than or equal to minus 5. These points, are they still irrelevant?
No.
No. This is where it is less, this is about 0. Now it's about minus 5. There's a couple of ways you can do this. You can do it with and without the calculator. With the calculator, if you draw this graph and this graph, it'll be helpful. So let's do with the calculator first. Hopefully we have time. Yes. Yes.
You can go put the minus 5 on the other side. So it's equals 0. No, it's.
What's the question?
Can we get 4x?
You can, that's the algebraic method. If you try and solve it equal to 0, you would get the same answers. Let's see, can we solve it quicker on the calculator? So I put in that function, and I also want to put in the negative 5 function. So I've got the one initially, and I got negative 5. That's where I want to see where they're going to be at. Now, my previous window was a bit messed up because I had a different question. So I'm going to set that back to minus 10 plus 10. So I get a good idea of what it looks like. Okay, I have a happy face graph, which is what I wanted, and I've got some line crossing it. Where is this graph less than minus 5? This line across the screen is minus 5, this one. Where is the graph less than that line? All this bit down here. So if I find where it crosses here and here, that is where it's going to be less than minus 5. How do I do that? Second trace. I'm looking where those two lines intersect. Where is... I'm looking for this. I'm going to look for this point first. So I put on the first curve to the left of it, on the second curve to the right of it, press enter. I see the x is on that spot at minus x is equal to minus 1.75. Now I need to find the other one. Put one curve on the left of it and the second curve on the right of it. Press guess again and I get x is equal to 1. Okay, so I want between these two numbers. So x lies between these two numbers. X needs to be greater than minus 1.75 and x needs to be less than 1. But then I remember the question said greater than or equal to. So it can be equal to 5 as well. So I put in the equal buttons. Their sign. Now to do that algebraically, I don't know if we have time. Is this the last page? No, I have to finish this tomorrow or Friday. To do it algebraically, I will do 4x squared plus 3x. Bring that back over and make that plus 5. That's minus 7. You can equal it to 0 for now. We'll come back to that. Factorize it. Uh, 2x is it? No, x, 4x. Yeah, 4x, x, 7, 1. These two make 7x. These two make 4x. We have to make plus 3x. Plus, minus, plus 7, minus 1. Solve that. X equals 1, equals 0, and x equals 7 over 4, minus 7 over 4, which is the same as this if you change it to a decimal. Once you have those 2 points, just do the same thing. Here, you're just looking for it where it crosses. Okay,